Dear students and participants on the course on railway engineering, today we are going to start a discussion on another topic, which is rail control systems. In the previous lecture, we talked about the leftover interlocking systems, and the last one which we discussed was the electronic interlocking. We discussed about the various features or the essential requirements which should be there when the electronic interlocking is to be implemented. And then 4 technological features which have been adopted and implemented on Indian Railways were discussed, which were train protection warning system, the last vehicle check device, the train circuits and the axle counters which are part of the train detection, and the anti-collision devices. In today's lecture, we will be talking about the approaches which are there to control the movement of the trains on the tracks or the sections. And in this light, we will be discussing about few of the definitions, and then finally we will be taking up one of the system which is known as absolute block system. We will look at the salient features and the working of this particular system. Now, what are the basic objectives when you talk about a train control system? So, the basic objectives are that it allows the operation of the trains in either of the directions on a track. It allows the faster trains to overtake the slower trains, because you have the trains which are moving at different speeds. So, the categorization is there. Considering that categorization, this type of a opportunity needs to be given to the faster trains, otherwise there will not be a faster train at all, because if each and every train is following the other trains, so all the trains will be moving at the same speed. The journey time are also going to be the same. And the main objective which always remains is the safety of the trains. And when we say the safety of the trains, it means we are talking about both the passengers and the freight, and the third component can also be attached here, which is the rolling stock, the operators on the train. So, those parts can also be discussed in terms of the safety being given. In general, there are two broad approaches when the train control systems needs to be devised. One is a time interval system, another one is a space interval system. Of course, in both of the cases, the safety is going to remain a primary concern, and we are only trying to see that how the safety can be achieved when there are two trains which are moving, say, in the same direction on a same track, or there is a train which is coming from the other direction on the same track. So, in the case of time interval system, the sufficient time interval gap is maintained between the dispatch of the two trains in the same direction on the same track. It means now what we are saying is, okay, when these trains are moving on the same track, then this particular distance is x minutes. So, that is how the time interval system is being working. In the case of a space interval system, by the name itself we can understand that some distance is being created between the movement of the two trains, and that distance is defined in terms of a block section, and it is marked. So, number of block sections will be there. So, that is how the trains are moving. So, how many blocks gaps are going to be there between the two trains is what we are talking here in terms of the space. So, this is the total space which needs to be there in terms of now n blocks. So, whether n is equals to 1 or n is equals to 2 or it is more than 2, that is the point of concern here, and depending on which particular system is being adopted, we are going to see that how many block distance will be there between the two trains which are moving on a section on a particular track in the same direction. So, in the case of a space interval system, this cannot be occupied by another train till the first train has cleared a certain distance. Now, some definitions here. The very first one is an adequate distance. This adequate distance is a distance which is beyond a signal that must be clear before the previous signal becomes off. So, you have a signal here. Here in this case it is a red color condition, it means nothing can move. So, till the train moves ahead by some adequate distance with respect to the signal which is in the advanced condition, that is this signal 2. So, that distance is what we are talking here, is an adequate distance. So, as soon as the train goes beyond that, then only we say okay, now this total distance is available for another train as a clear distance between the two trains moving on the track in the same direction. Block section. Block section is a distance between the last stop signal of the rear station. Say here this is a rear station 1 and this is a advanced station 2. So, on the rear station this is a last stop signal which is an advanced starter here, and in the case of station 2 there is going to be a home signal. So, the home signal is being provided here. So, what is the block section? Block section is the distance between the point here and the point on the other side which is related with the home signal plus adequate distance, because we already talked about this, that there needs to be an adequate distance. So, this adequate distance is provided here. So, that is the total distance which we are talking as a block section. So, now you must have understood when we have been talking that the train has moved into a block section or the train is in the station section and so on, and what was the basic difference between these. So, station section in the case of a double line, between the outermost facing points and the last stop signal of the station in either direction. Okay, so, that is the distance which we are talking in terms of a station. So, when you are talking about a station, outermost facing point and the last stop signal. So, when you are talking in the sense of a last stop signal, say there is a station here, that is a track here, there are going to be the starter signal, the advanced starter signal, at this point the home signal and the outer signal. So, with respect to this outer signal and the last stop signal, we are discussing the distance, or it is between the BSLB. So, what is BLSB? So, this is a type of the board, the limit. So, what was that if you remember? So, that the abbreviated form was the block section limit board. Now, when these are being provided and the LSS of the section in the either direction, so in that case this can be the distance and can be used as a station section if the double lines are provided. In the case of a single line, it can be between the shunting limit board, that is SLB, or the advanced starter if any, or between the outermost facing points if there are no SLBs or advanced starters. So, there are different ways in which we can identify that which is going to be the station section. Now, let us look at the diagram which is being given on the right hand side. So, this right hand side diagram is talking about a block section. So, here you can see this is the last stop signal for the station A and this is a station B. And in the case of a station B, we are taking the first stop signal of station B here. So, this is the first stop signal plus adequate distance. That adequate distance which we are taking is also known as the block overlap, and this total distance being considered as a block section. Now, here if you see there is a single line and a double line condition. So, we were talking about the station section for a single line and a double line. Say in the case of a double line, this green patch is being shown. So, when it is coming here, what you can see what it says for the single line is shunting limit boards or advanced starters or outermost facing points or advanced starters. So, if they have the advanced starters being provided here, so those were going to give you an idea about the station limits or sections. In the case of double line, so double line means this is facing points and the advanced starter, or a facing point condition and the advanced starter. So, the limits are changing a bit in the case of the double line system. You can see in one case it is starting from here, but on the other line it is not ending here, there is a distance, and that is a gap which is coming on the other side too. The station limits portion of the track which is under control of the station master, this is between the outermost signals of the station and may be as specified. Okay, so, whatever are the outermost signals at a station, so that particular limit is under the control of the station master. That means, the outer signal on one side and the advanced starter signal on the other side. Then block back. Now, what is this block back? This is dispatching a message from the block station to the block station immediately in rear on a double line, or to the next block station on either side of a single line, that the block section is obstructed or it is going to be obstructed. When we say obstructed, it means it is being set and the train is moving in there. So, that is what is an obstruction we are talking here. So, what it says here, but you can see that if you are talking about the two line system, double line system here. So, station 2 blocks this line. Why this station 2 blocks this line is that now the train is going to move from here. So, this is being blocked. Similarly, when the train is coming on this direction, then the station 1 blocks here. Block forward, this is a dispatching a message from a block station to the block station immediately in advance on a double line, that the block station in advance is obstructed or is going to be obstructed. So, in advance of a signal, this particular section, that is what is an we are looking here. So, now the other two terminologies are in rear of a signal, in advance of a signal. So, with respect to the condition position of a signal, the section which is ahead of it or a section which is at the back of it is what being talked. So, here the territory over which a approaching train has to pass before reaching the signal location is in the rear, and the territory beyond a signal as seen from the approaching train is the advance of a signal. Then overlaps. This is the length of the track in advance of a stop signal, say S2, which must be kept clear either for the clearing the stop signal next in rear S1 or for the purpose of granting permission to approach. So, there is a particular length which we are talking here. So, this length is being shown in this case. So, this is in advance of the stop signal, this is a stop signal S2. So, just in advance of that, here we are looking at in the rear as S1. So, this is the route of signal S1 being set, and there is a overlap of this signal also, and this overlap of a signal is defined as signal overlap. And as you can see here that the train is moving in this case, which is a multi-aspect a color light system. So, here when the obstruction means here the train is moving. So, the signal overlap of 120 meters needs to be there, then it says now it is red and the other one is showing as a yellow. That means the train has moved beyond one section or the distance between the two stop signals. So, here in this case again you can see this is a distant signal, this is a first stop signal, the train is moving here. So, there is a block overlap, and between the first stop signal and a distant signal there is a distance of 1 kilometers. We have discussed about these placement of signals when we did talk about the signals. Okay. So, the signal overlaps in the case of MAC-LS is 120 meters, automatic signaling on double line is also 120 meters, or in the case of single line also it is 120 meters. That means whenever signal overlap SO is being talked, we are working with 120 meters. Wherever we are working with the block overlap, then this block overlap is 180 meters. Braking distance, the distance travelled after application of the brakes by train or a locomotive. Service braking distance, we discussed about it previously too, when the normal or the service brakes are applied, that is the power is being shut off and there is a gradual application of the brakes. So, here we are talking about the gradual application of the brakes, then the whatever distance is being travelled is defined as a service braking distance. The another one is the emergency braking distance. Emergency braking distance is related with the full application of the brakes and as well as the shutting of the power, because there is an emergent condition due to which the train has to be brought to a stop early, and that is what is EBD. Then side distances are other things which can also be discussed here. This is a distance over which the most restrictive aspect of a signal is visible from the locomotive cab or the cabin. Now, how this value is computed and to what particular thing it is going to be equivalent is what being talked here. So, this site distance is equals to or greater than RD plus EBD, where RD is the reaction distance. So, you are looking at something ahead and then you are going to react to that. So, you are trying to perceive the things, but in this particular time period the train is moving at the full speed. So, with respect to that full speed within this time period, whatever distance is being covered is RD, and EBD is that if there is a requirement of the application of the brakes in the emergency condition with full application of brakes, then that distance is EBD. So, a combination of these two is going to be taken as a side distance. So, it can be equals to or more than that, but then depending on the conditions the values needs to be taken. Say if you are talking about a 2 aspect signal, in the case of 2 aspect signal there is no pre-warning. So, in this it is taken as equal to RD plus EBD. But when you are talking about a multi-aspect signals where the pre-warning is already there, then in that case it can be equivalent to RD only, because EBD is already available between the sighted signal and the next stop signal. So, that is already a part of that system. So, you are having a 2 yellow lights and the yellow lights and then the red light and the green light. So, likewise it is already working. Now, coming to the train control systems back, again there are classifications in terms of whether you are talking for the non-block systems or you are talking for the block systems. In the case of non-block systems, again there are around 5-6 types of ways in which the train movements are controlled on the tracks. We will be discussing about those a bit later. But when you talk about the block control systems, then there are again number of things. The absolute block system and automatic block system, centralized systems are also there. In today's discussion we are going to focus on the absolute block system. So, what is this absolute block system? Let us discuss that. This is the most widely used system for ordinary train routes. The track is considered to consist of a series of sections such that when one train is occupying a section of a track which is defined as a block section, no other train is allowed to enter that section. So, we have sections here, and if there is a train which is passing in this particular block, so we have 1, 2, 3, 4 or 5 blocks likewise, it means no other train now can come in 2, 3 section or this 3 section. But then what is going to happen in 2 and 1 is also to be discussed. Now, system works on the principle of space interval. That means some minimum space needs to be maintained, and when we talk about this minimum space, this is going to be associated with the blocks. The block section is a section between the two stations having block instruments. Block instruments of the adjoining stations are connected together and they operate simultaneously in coordination with each other. We have discussed about it when we were talking about the key interlocking system. So, now the combination of the interlocking systems and the signals or the points is what we are talking again here. The permission to enter a block may be in the form of a physical token which is carried by the train crew. So, as soon as you operate the block instrument, a key will come out and then that key can be handed over to the loco pilot as an authority to move on that particular section. So, once that authority is there, then only the loco pilot will start moving. So, this is one type of system which we are discussing. The block section is usually taken to be a section of track from the most advanced signal controlled by the station in the rear, which is a starter or advanced starter signal, and the rearmost signal controlled by the station ahead, that means usually the home or the outer home signal. So, in between those two the block section is going to be there. In fact, just before this we have looked at the various definitions and there also we have talked about a block section in different cases. So, you can again revisit that and understand that what type of a section we are discussing here. Now, only one token is issued from the block instrument for a track at a time. That means, only one train is going to be given an authority to move on that particular section. So, there is no possibility of the train movements in the other direction on the same track, and that means now we are trying to maintain the safety of the trains which otherwise are required to move on the same track, but in opposite directions or in the same directions. The block section is separated by a station section. So, in between when you talk about a different number of block sections, then there will be a station section also, because we are talking this particular distance from where to where we are talking is in terms of the outer signals and the starter signals or home signals. So, that is the reason we are looking at it in terms of station to station. Now, block section is in the charge of both of the station masters, means the station master at station A and station master at station B, which are on either side of that block. They will be talking to each other before setting the section, before locking the section or before holding the section for the movement of the train. Sometimes a long stretch between the two stations may be formed into two or more block sections, and these two or more block sections, as they are being created, they are usually defined as intermediate blocks, and this creation of intermediate blocks helps in increasing the track utilization. Okay. So, otherwise if this is a station A here and there is a station B here and only one block is being provided, then only one train is moving in this direction or the other direction. But as soon as it is being divided into number of blocks and we are trying to maintain the safety, so there is a train which can move here, or there can be a train which is coming in this position, but at the same time there can be another train coming from the other direction, and somewhere here a system will be available where the trains can just pass each other by using the loop lines. The same principle applies in receiving a train from one intermediate block section into the next one. The signal controlling entry to an intermediate block section may be operated by a staff at one of the stations, or may have a small signal box also known as the block hut where the signal is located. So, this has been the previous method where you might have seen at certain locations some small hut is being created, a person is sitting there and that man is going to control the signal which is located with respect to that particular block hut. So, on the basis of the information received, those manual systems used to be done, but now when we are talking about the electronic system, electrical systems, then these are slowly going out. So, what are the essentials of the absolute block system? No train shall be allowed to leave a block station unless the line clear has been received from the block station in advance. So, you are going in the right directions, there is a station in the right direction, unless until they say the block is clear, the train from the station A cannot be allowed to move. Then double lines such as clear line shall not be given unless the line is clear, not only up to the first stop signal at the block station at which such line clear is given, but for an adequate distance beyond it. We already have discussed, that is a block overlap distance we have talked about. In the case of single lines, The line clear shall not be given unless the line is clear of trains running in the same direction, not only up to the first stop signal at the block station at which such line clear is being given, but also for an adequate distance beyond it, and it is clear for trains running in the direction towards the block station to which the such line clear is given. So, the definitions which we have discussed, with respect to those definitions we are trying to ascertain that it is not only up to the signal which provided here, it is basically for a certain distance beyond that signal. So, that is an adequate distance. It can be a block overlap. If it is a block overlap, then that is 180 meters which gets added. So, here you can see that there is a station A, there is a station B. So, the block section and the block overlaps are being defined. So, this is the last stop signal of a station A. This is the first stop signal of a station B, which is trying to set the direction in which the train is going to move. So, it says that the train has to be taken on the loop line here. There is a distant signal, the permissive signal. As you can see, there is a white disk on which P is written. So, it is a permissive signal being used. So, it can be a distant signal, Warner signal. So, here with respect to that distance between the LSS at the two stations, the block section is defined, and along with that, beyond the first stop signal at the station B, some distance is being taken, which is a block overlap. So, this is total what we are considering here. So, in the other case direction if you are talking, so here this is the last stop signal of the station B when you are moving towards A. So, here we are talking in this direction. So, this is the first stop signal of station A. So, that is one distance, and then there is a block overlap. Now, when we are talking about this distant signal or the permissive signal, so as we have seen that this is going to be 1 kilometer, this is going to be 180 meters. So, those distances we have already discussed. So, at a class A station on a single line or a double line, the line shall not be considered clear and the line clear shall not be given unless the whole of the last preceding train has arrived completely. That means, the last vehicle verification is being done. All signals have been put back to on behind the said train. So, the train is moving at a certain section. So, the back side it should tell that it is on or red color, there is no train being allowed to move in this particular section. The line on which it is intended to receive the incoming train is clear up to FSS plus the adequate distance beyond it. So, we have again and again iterating the same point. Or all points have been correctly set and all facing points have been logged for the admission of the train on the set line. So, when we discussed about the interlocking systems, this is already taken care of. Now, what is the working of the absolute block section? Let us talk about the blocks A, B, B, C. There are 3 stations A, B and C. The train is approaching from behind station A and is moving in the direction of C. So, that is a scenario. So, here you can see that this is a station A, this is a station B with the station B limits, and that is a station C. So, there is one space available here, there is another space on this side. So, this is also a block section. If this is a station, there can be a station section here. There can also be this is a station section, then block section, station sections and block sections. Likewise, there are different sections which are provided. And there can be different possibilities where the trains can be there. So, the controller of the trains informs the station master at station B to receive the train which is approaching from station A. So, there is a train at station A which is going to move to station B. So, for that the controller is going to inform, and accordingly now the station master at A and B, they are going to talk with each other and they are going to see whether the line clear condition is available or not, and if the line clear condition is available, accordingly they are going to set the signals, they are going to set the points. So, the controller of trains in control room controls roughly 300 to 500 kilometers of the section, which comprises of 40 to 50 block stations, and the train is going to move between those block stations. Now, the station master at B, through verbal exchange, discusses the situation of the track with the station master at A, and if both agrees, then they are going to operate the block instruments, and these block instruments are going to be operated simultaneously, so that the keys comes out at one station and it locks the system in both of the cases. So, that once this key is being taken to the another station is being inserted, then only it is going to be released. So, the station master at A will operate the right side block instrument, and the station master at B will operate the left side block instrument. So, they are now going to operate. So, this is the right side and the left side instruments are being operated so as to generate the authority. This will give one token at station A, and both the instruments will become inoperable for any other token. As I said, but this token is going to be utilized because it has come out, is going to be inserted at station B, and that will open only and only when the train will reach that station B, and it will hand over, the loco pilot will hand over the token to the person, and it is going to be inserted back. So, this way no other train can be allowed to enter the block section, that is AB. Now, station master at A then informs the east cabin man to set the points and lower the signal to the off position to receive the train, or sorry, to dispatch the train from here, because now the train is going to move forward towards the station B. The token is handed over to the loco pilot as an authority to move on section AB. The train starts moving on section B. So, towards B it is going. So, this is how the position will come. Now, station master at B, through verbal exchange, discusses the situation of the section BC with the station master of station C. So, now the station master C comes into consideration. Now, these two are communicating. If informed by the controller, they will operate the block instrument simultaneously. Now, when they are operating the block instrument simultaneously, it means here right and here left, these two instruments are going to be operated, and as soon as they get operated, this section is going to be set and locked. So, a token will come at the station B for the movement in section BC. Then further, the station master B will inform his west cabin. Now, this person is going to inform to the west cabin here to set the points and lower the signal to off position for receiving the train. Now, whatever the signal is there, it will allow the train to come in, and if it is being taken on a loop line, so the loop line signal is also there and it will call the train on the loop line. After the train has arrived, the points are restored back. Token is handed over by the loco pilot at station B. So, here now the token will come, and this token will be inserted in the left side of a block instrument. So, as soon as it is being inserted on the left side of a block instrument, now both of these instruments, the right and the left, they will become operable, and this section gets released. Now, the station master and B informs his east cabin man to set the points and signals to off position to dispatch the train on the section B. That means the procedure is now going to be repeated. Now, the token for the section BC is handed over to the loco pilot, and the train will start moving in this section BC. So, the things are happening that there is a communication to see the line clears are there or not, then there is a communication in terms of a block instrument, there is a communication of the station master with the cabins provided to operate the points, and then finally everything is being set, the token is being generated, is being given as an authority to the loco pilot to move on the sections. So, that is what we have discussed in terms of a absolute block system. So, in this particular lecture, we talked about the train control systems, and before starting that discussion, we have looked at the various definitions which are important in terms of the movement of the trains on the section. So, we talked about adequate distance, we talked about side distances, block sections, station limits, etc. And then finally, we have looked at the various salient features and the working of the absolute block system. We will be taking up the rest of the train control systems in the next lecture. Till then, thank you and bye.